Well, welcome to another video where we're going to be discussing the memorandum, or at least the mid-year exam, and we're at question 3. We did question 2. Question 3 in our mid-year exam was our calculus question, and very straightforward. I don't think there was anything really very difficult. So it's once again, it's one of those topics students find it difficult, but it's really not. It doesn't have to be difficult if you understand the work. So let's get into it. First question: find the derivative of, and then they give us that expression 2x squared plus 1 from first principles. Now, I don't think that is a very difficult question. I don't think students struggle with it much either, but let's do it. Okay, so here's our function f(x) is equal to 2x squared and then plus 1. Now, you might know that the derivative of this, and how do we get the derivative? We multiply the exponent to the front and then subtract 1 from the exponent. So the derivative of this is 4x. This one is x to the power of 0. 0 multiplied to the front gives me 0. So that's it. That's the derivative. And this is not from first principles. Just it's using the derivative law. But if we had to do it from first principles, we use this formula that the derivative is the solution of this limit. The limit of h tending to 0 in the expression f(x) plus h divided by minus f of x divided by h. And so what we want is we want to substitute h with 0, but we can't because we have an discontinuity, undefined value when h is equal to 0. So when we substitute, remember, as long as I don't substitute, this is one of the points where people lose marks, is they don't write down their limit. So as long as I don't substitute, I must keep my limit. And so what I substitute now is f of x. I'm going to substitute f of x in there and in here. But here just notice that instead of the x value, we substitute x plus h. So x squared gets substitute with x plus h. Whenever I substitute, I should use brackets. So everywhere I see an x, I'm going to put an x plus h. Squared plus 1. Now I'm subtracting. Again, I'm substituting. So minus, and then this is where a lot of other people lose their marks. Put it in brackets. 2x squared plus 1. Now the reason for the bracket is, and there was another example like this in question 2.1.2, where if you don't put the brackets, you forget that the negative must be distributed. Divided by h. Now you see, we can still not substitute the h, so we're going to have to continue to simplify. And simplification in these questions, this is a very easy one, but a simplification in these questions usually requires factorizing out the h and then cancelling it. So you'll see that's where it's leading to. When I multiply this out, I get 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1. And all of that is over the h. Still no hope of substituting. So my next step, this is now where you'll notice that everything that doesn't have an h will usually cancel. So that one, 2x squared minus 2x squared plus 4xh, sorry, that one has an h, so you will cancel, plus 1 minus 1. So I'm left with 4xh plus 2h squared. So this is then where I can take out my common factor h, and then I'm left with 4x plus 2h. At this point, I can now cancel my common factors. Remember, I couldn't cancel this h with that h because I can only cancel common factors. I have to factorize first, and then if there's a factor in the top, there's two factors now, this one and that bracket. One of them is common with the bottom or the denominator's factor, which is just an h and a 1 maybe. But after that cancels, I'm just left with a 1. So I don't need to write my divide by 1. And so I have the limit of h tending to 0 of 4x plus 2h. Now finally I've gotten rid of my discontinuity, so once I have gotten rid of that, I can substitute. The moment I substitute, I lose the limit notation. So now I just substitute, and I substitute h with 0, so plus 2 times 0 is just this. This is my final answer. And so here, obviously, this is so much longer than the quick application of my my laws, my derivative laws. But still, this is the actual formula of how we find it. And so there we go. That is how we find the derivative from first principles. And we did so in about 6 minutes, I think, which is exactly how much we need to answer that, but that's with explanation. So you should be doing it in quicker time than that. Now, the next question says hx is equal to f times g, where f is equal to, and then the square root of x, and g is equal to 2x plus 1. Write hx in terms of x with no radical symbols. Okay, so basically we're saying substitute f and g. So and then we should simplify. So h of x is equal to fx times gx. Substitute, so square root x times 2x plus 1. Let's confirm. Yes. And then we must just simplify. So 2x times the square root of x is x to the power of a half plus x to the power of a half. Okay, so all I did was just multiply this in, and then I'm just going to simplify this further. 2x 3 over 2 plus x 1 over 2. Okay, and that's it. The next question is find the derivative of hx. The derivative is now just multiplying this in front, so the 3 over 2 times the 2 gives me just 3x. 3 over 2 minus 1, so that's 1.5 minus 1 is just a half, plus this side is 1 over 2 because there's a 1 in front, so multiply gives me a half. X times, and then a half minus 1 is minus a half. Excellent, you don't need to go any further. You'll see it counts 2 marks, so it's 1 for every term. And now they ask me, okay, show that the derivative of hx, the one we found just here, is also equal to the derivative of f times g. So I must find the derivative of f multiplied with the expression of g, and then plus f, which is just square root x times g. So I already have this side, but now let's go and look at the right hand side. For the right hand side, I need the derivative of f x, and since f of x is so it's just this, I need the derivative of that. Okay, so a different way of writing the derivative, and the derivative of square root x is just this part here. Okay, is just a half x to the power of negative a half. Okay, and then for g, the derivative of g. G was just 2x plus 1, so his derivative is just 2. So if we substitute that into the derivative of x times g, this is now the expression they want me to show is equal to the derivative of h plus g derivative times f, or f times g, whatever that was, doesn't matter. But this is called the product rule. So when I have an expression like that, when I find this one's derivative, it's equal to that. So it's not something we do at school. It's a rule we only learn at university, but it's something we can still do. We can still prove that in this case it's true. So let's see, what is the derivative of f is a half x to the power of negative a half times g, which is 2x plus 1, plus the derivative of g is 2 times here x to the power of a half, which is what fx is. And now if we continue with this, we just simplify. So we have that negative a half times x to why do I have negative a half there? It's not negative, just a half, sorry. Okay, so I have a half times 2x, or a half times 2 is just 1. So x negative times x 1, x negative a half times x1. I add the exponent, so I get 1 minus a half, which is just a half. Okay, that's for that first one. That next one is plus a half x to the power of negative a half, plus plus 2 x to the power of a half. Okay, and so now I just simplify this. Here is x to the power of a half plus 2x to the power of a half. They are like terms, so we can add them together. So I've got 3x to the power of a half plus a half x to the power of negative a half. Okay, and that's exactly hx. 3x to the power of a half plus a half x to the power of negative a half, which is equal to h, the derivative I mean. Okay, here we go. Let's move on. So this wasn't difficult, but I don't think many people got that question right. But it wasn't really difficult. Here is a topic that students really struggle with, and I have no idea why. This is so simple. So I don't know. Maybe I've just done it so much that that it just comes so naturally to me. But it's really not a difficult topic. The point about cubic polynomials, as you can see, cubic polynomials is in the question with derivatives. Now, instead of saying derivative, we should call it the gradient formula, because that is what the derivative is. It's a gradient formula. It tells us what the gradient of a function is. Okay, so for example here, for which values of x is the gradient equal to 0? The gradient is just the steepness. Where is the steepness equal to 0? It's so simple to see. Well, it's at the turning points. There's no steepness there. A tangent line lies horizontal. So where is the derivative equal to 0? Well, always at the turning points. So for which values of x? Well, if I'm at that turning point, the x value is -9 and 5. So again, notice the marker location. Always look at marker location. It's 1. So for which values? It should be something you read off. Okay, -9 for x equal to -9 and x equal to 5. Next question. For which values of f is, and again, don't read this as the derivative of f. Read it as the gradient and not greater than 0. Say, where is the gradient positive? In other words, uphill. Where is the gradient going up? Well, and again, for which values of x? Well, it's for this. Here the gradient's going up. There I'm going up. Oh, here I'm going down. So it's not this part. Then I'm going up again. So what is the x values for this part of the graph? Well, and there's an arrow pointing down, but if you can see, it will always go down. So for all the values that's less than -9, okay, so x is smaller than -9, and it doesn't include it, so it's just x smaller than -9. And for here, for all the x values bigger than 5, it's positive. So again, I don't know, I can probably count on my one hand the number of people that got that correct, but all the values of x greater than 5 is positive. Anyway, moving on. Determine an approximate sketch graph of the derivative of f. Not of f, the derivative of f, indicating the correct x-intercepts of the graph. So here's a cubic polynomial. Let's just look at this briefly. I mean, it's such a simple concept. Here is a cubic polynomial. We know it's a cubic polynomial because it has this this double hump. Okay, there's a turning point and there's a turning point. Cubic polynomials have 2 turning points. Quadratic polynomials, in other words, a parabola, has 1 turning point. So anything x to the power of 3 will have 2 turning points. Well, it might look like this. It might be that the 2 turning points coincide, so as these turning points can, for example, come closer and closer together, so that it's more like a little kink. But the point is, one end of it will go down, the other end of it will go up. Okay, where if the parabola, if one end goes down, the other one will eventually go down as well. A linear polynomial doesn't have any humps. So x to the power of 1 has no humps. X squared has 1 hump. X cubed has 2 humps. Okay. So in other words, remember that the derivative gives me the gradient. So if I take the derivative of x cubed, it would be 3x squared. So the exponent, we call it the degree of the derivative, tells me how many turning points there will be. We know if we make this equal to 0, we're supposed to get 2 answers. Okay, so that tells me there's 2 points where there'll be 0 gradients. For this, x squared, if I take the derivative, I get 2x. Okay, so and this equation, if I make it equal to 0, obviously there's more things there, so it's not just going to be x equal to 0, but point being, there will be 1 answer. So why do I say all this? Well, if f of x is a cubic polynomial, ax cubed plus bx squared plus cx plus d, you don't have to do all this. This is just part of the theory. So it's something you must know. If this is a cubic polynomial, then the derivative of this expression will be 3ax squared blah 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 blah. I don't want to say the rest. All I want you to notice is that the derivative is a parabola. It's a cubic equation. So whatever we have here, all we need to know is, first of all, we just need to know, is this a positive? Because notice here that my parabola is going to be plus 2bx plus c. You don't need to know this, you just need to understand that the first, sorry, you don't need to do this, you do need to know this. The first part tells me my shape of my parabola. Is it going to be smiling or frowning? Okay, now we can see that it determines what a is. Is a positive or negative? We know a positive a will make this 3 times a positive number, so it will be positive, will give me the smiling face, and this one will give me the frowning face. Okay, if a is negative. So I need to go back here and ask, well, is a positive or negative? Well, a positive cubic polynomial looks like this, a negative one looks like that. Okay, so I can see, well, the one we've got in our sketch is a positive one. See it, the n shape. The n is positive, the upside down n is negative. So I know that this is already what my graph looks like. So here was the first point given. And so you can just always know, if they ask you to draw a sketch of the cubic polynomial's derivative, In other words, his formula for the gradient, if I wanted to draw a cubic polynomial, for, a graph for that one, I immediately know it's a parabola. My first question is it smiling or frowning? Well, it depends on this one. This is the smiling one, the normal n. Yeah, I'm happy with the way you write my n. Or if you write your upside down n, I'm sad. Okay, don't know. I'm dumbing it down. Hopefully that helps you to remember. But then the question is, well, where does this cut the x-axis? Where does my derivative equal 0? Because remember, when I cut the x-axis is where my y value is 0. In this case, it's not a y value, but my actual derivative, my formula value. And we already worked that out in question 1. That was at -9 and 15. 5, sorry. -9 and 5. So there we go. I mean, there is 3 marks. I spent a lot of time trying to explain it, but you just needed to know that this is a smiling parabola, whoop, and it cuts the x-axis at the point where this one turns. So, don't know how to make that any simpler. Okay, if x is minus k is equal to 0, has only one root. What are the possible values of k? So, when I have something like this, it's more helpful to go and rewrite that as if, let me change colors to keep your attention. If x minus k is equal to 0, so f of x is equal to k. It's more helpful to write it like that. And the reason why is because this is just my graph is equal to another graph. Now, how do we get points of intersection? Or how do we find out where two graphs are equal? We find the points of intersection. The question is, well, what graph is this? Well, this is just the graph of, let's call it gx is equal to k. So in other words, it's where do these graphs, gx equal to k is just a horizontal line. It's a constant function, horizontal line. So where can I draw a horizontal line so that fx, so that it cuts this graph only once? Well, if I could draw it here, it's going to cut twice. There, sorry, 3 times. 1, 2, 3. There, 1, 2, 3. And I see as I get to the turning point, there it will only cut once, twice. Ah, that's not going to work. But any point higher than this turning point will cut only once. Same with the other turning point. Any point lower than that turning point will cut once. So in other words, if for the question was, what values of k, in other words, the horizontal line value. So anything higher than this value, which is a, and anything lower than that value, which is b. So for k greater than a, or k smaller than b. Okay. Okay, now if y equal to -135x is a tangent line to f at x equal to 0, what is the derivative at the point 0? So what they're saying now is that if we draw a tangent line at x equal to 0, its equation is y is equal to, and there. So here's a line passing through the origin with a gradient of -135. So what is the derivative at 0? What is the gradient of f, of this graph at 0? Well, that's the point. A tangent line has the same gradient as the graph. So this one's gradient at x0 is equal to that one's gradient at x0. What is this one's gradient? 135. So 1 point. What is it? It's 135. And that's it. Great. This one, wow, what a beauty of a question. Actually, this was a horror of a question. but not really. It depends on how you approached it. But here they simply say, okay, we have a plus b is equal to 10. Find the maximum of that value. Okay, so let's go. I'll need some space for this one. Okay, 7 marks. This thing must be 10 pages long in a math exam, isn't it? A plus b is equal to 10. Find the maximum of a squared b cubed. Okay, we want to find the maximum value of anything. To find the maximum of an expression, okay, let's call this one, let's call it m. Okay. To find the maximum value that m can have, if a plus b is equal to 10, I must find the derivative of it in terms of one of the two. But I can't find the derivative in terms of one of the two because I still have two variables here. So I'm going to replace one of the variables. Now, in order to replace one of the variables, I can just use this expression. So, for example, I can either use b is equal to 10 minus a, okay, or I can use a is equal to 10 minus b. Okay, now which one is going to be easier? Is it going to be easier to substitute in b is 10 minus a and then take the cube of that, or maybe to substitute a is equal to 10 minus b, so 10 minus b, and just take the square of that, times b cubed is equal to m. Not m derivative, that's what I want to find. Personally, I think that's much easier, okay, to find that. Okay, and let's see why. So if I now do multiply this out, I get 100 minus 20b minus plus b squared times b cubed is equal to m. So now I simply multiply in. So b, I'm just going to write it in reverse order. So b5 times minus 20 b4, and then plus 100 b3. Why did I multiply in? Aren't I going to put this equal to 0 and then I don't have to find the factors again? No, I first have to find the derivative because I want to find the maximum value. The maximum value is the turning point. Like, this is the absolute maximum value that it has in a local setting. So this guy is the main peanut in the packet. We want to find out the turning point. So to find the turning point, we want the gradient, and then we substitute it. Okay, so first I have to find the derivative, and to find the derivative I must first simplify. So now when I find the derivative, I get 5b to the power of 4 minus 80b to the power of 3 plus 300b squared is equal to the derivative. And I want to now make this derivative equal to 0 and solve for b. Okay, so if I do that, take out, I factorize. Now it's a matter of factorizing. Now this is ridiculous factorizing because look at that, b to the power of 4, ugh, okay, but no, it's not really that. First we look for the greatest common factor. The greatest common factor is 5b squared. Here's a 5, I can take 5 from everywhere. Each one has a b squared at least. So I'm left with b squared minus 5 divides into 80 16 times, b, plus 5 divides into 360 times, is equal to 0. So I have either b squared or 5b squared is equal to 0, or this one. Okay, so let's first do that. We can divide the 5 on the other side. So b is b, and then this goes into two brackets. B both has to be a negative. What times what gives me 16? When I add it, I get 16. Oh, that's easy. 10 and 6 is equal to 0. So in other words, I get three solutions for b. Either b squared is equal to 0, so that can only be when b is 0, or when b is equal to 10, or when b is equal to 6. So there's my three solutions. Now what will a be if I have that? Because I want, these are the values that will give me either a maximum. Remember, that's what I have here. I either have a maximum or I have a minimum. Now here, this graph actually looks like that. So there's going to be two minimum values and one maximum value. And here's the two minimum values. Let me show you why. So if b is equal to 0, by the way, you didn't have to know this. You were simply following the steps. You have an expression that you have to find the maximum value for. So all you do is you write that expression in with a single variable, so that you can find the derivative in that single. And you could have chosen a or b. A would have just been a nightmare though, because you would get to you wouldn't have this common factor. It would have been a completely different story. But anyway, I chose b, and that made it much simpler. And then in the end, when I after I've simplified it, found the derivative, made it equal to 0, and I now get three of a certain number of values where I will find the derivative is 0. In other words, where I will find turning points. Now these turning points might either be minimums or they may be maximums. In this case, they are both. So if b is equal to 0, a plus b is 10, so a would be 10. Is b 10, a would be 0. So in other words, if I have a squared b cubed, if one of the two is 0, the answer is 0. So if a is 0, then this whole expression will be 0. If b is 0, this whole expression will be 0. So in this case, both of them will have give a minimum, a local minimum at least. So then there's the other one where b is equal to 6 and a is then equal to 4. So this would be the maximum values. So maximum value will occur when we have 4 squared times 6 cubed. And that gives us 4 squared times 6 cubed. That is not right. 4 squared times 6 cubed, there we go, is 3, 4, 5, 6. Isn't that a beautiful number? 3, 4, 5, 6. Ah, love it. Cool, and that was a total of 29 points, for which you have 29 times 1.2 is equal to 34. 35 minutes. I've done it for you in 33 with explanations, so there's more than enough time. Which ones should you have spent time thinking about? Well, this first one, yes, there's a lot of steps, but you should be able to do it in a little bit less than the time. This one, yes, this one might have required some thinking, so if you spent a little bit more time on it, that would have been fine. But if you didn't know, if anything made you feel unsure, just move on. This is where you should have made up your time, because you should have immediately known, turning points, increasing interval, drawing the sketch, parabola. This one, maybe you should have thought about that one, but it's a common question in exams, even though it's a level 3 question. Very common question, and so you shouldn't have a problem with that. You'll almost definitely get another one like this in your final and prelim exams. This one, maybe you should have thought a little bit, but again, the point value should have told you, this is just, I should read this off, I'm sure. And so even if you guessed just negative 135, yes, here's where you're probably going to spend time on, but for 7 marks, you almost have 8 maybe almost 9 minutes that you have for answering this question. So that is a lot. Nevertheless, thank you very much for watching. I'll see you in the next video with question 4.